Welcome to lesson 5 of the science class. So today we're going to look at the Numpy. So Numpy is one of the extension tool in Python. So Numpy is a popular Python library used for numerical computing. So it provides support for handling large multidimensional arrays and matrices, along with a wide variety of mathematical functions to operate on these arrays efficiently. So we're going to look at how we can be able to define and manipulate the Numpy array. Then finally, we'll look at how we can be able to apply descriptive analysis, right? How we can be able to explain descriptive analysis using the Numpy extension tool, okay, in Python. So go to my Visual Studio, right? So remember the last previous class we did dictionary. So here I'm going to create a separate script. So I'll call it maybe num.py. Okay, so now to use Numpy, we have to import Numpy as np. Okay, you can see that I don't have the Numpy here in my library, in my virtual environment. All I need to do is to download it from pip install Numpy. Right, so the first thing we do here is to import the Numpy extension to, right, as the np or as any name. It's not necessarily like it can be np, it can be John, it can be any name, right? But it's this same variable np is one of the popular names being used in different videos, right? So now the first thing we start before we look at descriptive analysis, how we can do descriptive analysis, right? We're going to look at how we can be able to perform key features of Numpy, right? How we can be able to perform key features with Numpy. You can see it's downloaded here, but while it downloads, let's just do something. So the first operation I'm going to do here is the n-dimensional array, right? So Numpy provides an n-dimensional array object that represents a multidimensional homogeneous array of fixed size items. So let's do some examples. So you can see the first time I import the Numpy, right? So I'll create a variable. Let's call the variable array equal to np that array. Remember this, the np is a Numpy, right? So that array. So I'll pass an integer data type elements to this, integer elements to this, okay? So you can see what happens. So if I print this, it automatically prints these elements for us, right? So now it won't actually show because I'm trying to install um, the Numpy. It's about 20.6 MB, right? So let's do some calculation. You can see this one is for the n dimensional array. Okay, so we are going to look at what we call the element wise operation. The elements wise operation, right? So now we can perform mathematical operations on array in an element in a wise manner, right, which is efficient compared to the traditional Python loop, right? So instead of you using the traditional Python loop, right, you can actually use Numpy to do that. It's a shortcut to it. So all I just need to do is to have my array one, right? Let's assume I have my array one, which is np.array. So I call this 3, 2, 4, 8, 7, 7, 8, 8, 99, right? So I have my array 2. I'll copy this. I have my array 2 np.array. So let me just change this. Okay, now I want to do some I want to add this array to this array. I want to do an addition here. So all I just need to do is to pass a variable called result equals to array1 plus array2. Right? You can see how easy it is, right? So once I print this result, it will add up this for me and we'll see it after this Numpy is stored. So the other one we're going to look at here, right? So Numpy allows you to do a linear algebra calculation, a matrices calculation, and many other stuff that you can actually do in many other mathematical operations, right? But this is not a mathematical class. This is a data science class. So we'll move straight to descriptive analysis, right? Most of you can be able to use Numpy for descriptive analysis. So we all know that descriptive analysis, right, is a process, right, of summarizing and describing the main features of a data set. So you can use Numpy for basic statistical calculations, right? So like the mean, the median, the standard deviation, and other measures of central tendency and dispersion. Now we're going to look at that. We're going to explain that. Okay. So what we'll do in this class is to calculate the mean, the median, and standard deviation, right? The variance, the first quarter, second quarter, and the third quarter, right? So I'm going to explain that in this PowerPoint here. So let's assume, don't worry about these data sets. I'm going to explain how the structured and unstructured data sets works, how the what is dependent variable and dependent variable in the next class, right? So now what we want to do, we want to follow up this, we want to solve a problem, right, using NumPy. So I will pick a age here, this age here. We have a table which contains the column and rows, right? So each of these tables have customers, right, with their different attributes, with their different records, right? Their different information, maybe the one information, right? So I want to pick this age. I want to work on the age. I want to work on the age. So let's assume we want to find the mean, right? To find the mean here is the average age, which is, right, I'm picking the age now, right? I'm picking the age. So the mean is the sum of all ages here divided by the number of ages, which is equal to 34, 45, 23, and 50, right? So it gives you, add up these, then the total number of ages is 4 divided by 4 gives you 38. So let's do that with NumPy and let's see how it works, right? So we are in the descriptive analysis. So I can call this array, right? So which is np.array, np.array. Then I will pass, let me pass this. We have 34, 45, 23, 50. 34, 45, 23, and then 50. Okay, so we have this. I'll pass the ages. I'll pass the ages to the NP, to the NumPy, right? So now watch how easy it is. It's not like using your traditional an array, your traditional list where you look through, right? So we already have the functions inbuilt in the NumPy extension too, right? So all I just need to do here is, and let me write a variable called mean, right? So all I just need to do here is to say then np that's the mean. You can see it has a function called mean, it has a function called median, and look at all the functions are coming out here, right? Look at all the functions here. So I'm using mean, right? So pass, then I'll pass the descriptive, this variable here, because this variable holds the array here, right? So once I print the mean, it will definitely give me the mean of this, right? So my NumPy library is successfully installed, so I can start running this. So I have my pad, num.py. Okay, it gives me 38.0. Let's find out the same answer. What we have here? Okay, we have 38. So what it gives me here is the mean, which is 38.0. You can see how it works. You can see the code is short. So that's why Python has provided this necessary extension to, right, for us to work easily, right, and faster. Right, so if I'm using the traditional Python, I'm going to look through this and then divide, get the total number of length and then divide by the total number of elements that we have. Right, get the sum here, the total sum that we have, and then divide the total number of elements in the array. But you can see here just 3 lines of code. The first one is to pass in the arrays down to this variable called descriptive array, right, to store it here, and then call the main function in the numpy should I call it the numpy library or the extension tool? Now call it and then pass this to it and it gives me the answer, because this mean here we already have the function inbuilt right in this extension, right, or in this library, like a library. So we already have this main function in here. So I'm not writing a main function anymore. I'm just calling the function be written here, right? So it makes my work so easy. So what about median? So let's move on to the next one here. So done for this now for median, right? So you can see for median we have even number here, and we're trying to get the median, right? If it's an odd number, we'll just pick the middle, right? It gets the middle number, right? And the middle number becomes the median, but because it's odd, it takes the two middle ones, which is 45 and 20. It takes the two middle age, which suppose, because I did is a mistake, right? So you're supposed to take these two middle age, which is supposed to be um, 45 and 23. But if it's in an ascending order, if you are doing it in an ascending order, then 34 and 45 becomes the mid. Right? Okay, sorted ages. Okay. Now we're not looking at this. Okay, fine. For us to get the mean, this is the sorted ages. We throw into it 34, 45, and 50. So you can see that it collects the middle one, which is 34, and 45, which is the divided by 2, and then get the answer. So let's do that if this will give us the answer, right? So we have my median, called median, then NP is median, then I'll pass this. So if I'm printing median, let me just copy this. It gives me 39.5, right? So it's different. Okay, that's 9.5. So you can see what happens here, right? You can see exactly what happens. So what it does here is given a list of given a list like this with the elements, what it does first is first of all sort this in an ascending order, right? And then after sorting in ascending order, it fetch out the middle ones because this is even, right? If we have an odd here, if this is odd, it will just pick 55 as the answer, right? So okay, it picks 45 as the answer because this is not in an ascending, it's not a sorted array, right? So it's sorted out and pick. So let's make it sorted and let's see. So if we're making this sorted, right? So let me move to 5. For making this sorted already, we have the 23, 34, 45. It is sorted. It's not sorted, right? So if I have if I have 40 here, it will fetch out this 40 because it's odd number. So it's because these are odd 1, 2. The elements here have total number of 5. 1, 2, 3, 4, 5. So they are odd. That's why it's picking just the middle. It's not adding. But if they are even, right? So it's 1, 2, 3, 4. It picks the two middle number, right? And then add them and divide them by the total number by 2, right? So but you can see what happens. So in the best case scenario, this is already sorted. So in the worst case where this one is not sorted, definitely what it does, it will sort it out. Then once it is sorted in ascending order, it picks the middle ones. It pick the middle one. If it's odd, then it pick the two middle if they're even and then divide it by 2. So that is how it works. So let's move on to the next one here. So Numpy also have a function which is a mean. You also have a function which is mass, and you also have a function which is range, which range is the maximum minus minimum, right? Range is the mass minus mean to give us the range. So I'm going to okay, let's just do that here. Let's just do that here. So the mean is empty. You just write empty the mean and pass this to this and pass uh, the this array here, Numpy array. So the same thing applies to math. You can see we're not actually stressing ourselves to write any MP the mass, right? So it's this. Okay. So Then for range, for let's leave range, or should we just do it? No, let's just leave it. Alright, no, let's leave it. Leave it. Or we can do that. Okay, we have the range equal to np dot the pt, okay, ptp. I think that's this ptp is the function for range. Okay, then this. All right. So if I'm to print this, okay, I can say the median is, close this with brace brackets, then comma the, and let me start with the mean. The mean, okay, let me do descriptive analysis of the ages in our data set are the mean. The mean is, I'll call the mean, which is this, right? So the median is this, right? So the which one again? The mass is called the mass. The minimum is called the minimum, and the range is this called the range. Okay, you can see that my stuff is actually throwing an error, and if we leave it like this, right, not return anything because everything here is just string. So we need to format that so I can be able to see our variables, right? So to format that, just to put F here, and you can see everything here, right? So if I'm printing this, so the discrete analysis of the age in our data sets, the mean is 38.0, so the median is 39.5. Then the mass is 50, right? The mass is 50, which is the maximum. Then the minimum is 23. You can see the minimum is 23, and the range is 27. So the range is 27, which is the maximum minus minimum gives us 27. So let's do other ones. So let's look at the, okay, let's look at the standard deviation. Let's look at standard deviation. Now, how does standard deviation works, right? Now, using the age, now standard deviation, we need, the first step is calculate the deviation of each age from the mean. Remember our mean was, what was our mean? Our mean was 38.0. So the first step using the standard deviation, so what it does is calculate the deviation of each age from the mean, which is 34, right? The age 34 minus the mean, which is 38, will give us minus 4. Then age 45, so the deviation of age 45 is 45 minus 38 will give us 7. Then for age 23, the deviation of age 23, the 23 minus 38 will give us minus 15. Then for age 50, the deviation of age 50 is 50 minus 38 will give us 12. Now, after that, what we now do is to calculate the squared deviation for each age, right? So we use what we got here, right? The answer here, and then square them. So calculate the square deviation for each age, which is then minus 4 square, then 7 square, minus 15 square, which will give us, minus 4 will give us 16, 14, 7 will give us 9, for age 23 will give us 225, for age 50 will give us 144. Now it doesn't end here, so the next step is to calculate the variance. Now variance is equal to the sum of square deviation, right? Variance is equal to the sum of square deviation minus the number of ages. Remember we've got the square deviation, which is 16, 49, 225, 144, right? So it's the sum of the square deviation which we've gotten there, which is 16 plus 49 plus 225 plus 144, and divided by total number of what we have here, which is 4, which will give us our answer, which will give us 100 8.5. Now to calculate the standard deviation, right? Standard deviation is the square root of the variance, right? So the variance is 108.5, so the square root of the variance is the standard deviation, will give us about 10.4, right? 10.4. So we explain more of this descriptive analysis when we're looking at a thorough problem, right, for data science, like data science problem. So we're going to explain this descriptive analysis and then explain why this descriptive analysis is very necessary when analyzing your data. Okay. But this is just to show you guys how we can be able to use Numpy. We can also use we can next lecture we'll still use pandas to do all this, right? But I think pandas is far better than this, right? Just for you to understand the fundamentals of how you can do descriptive analysis using Numpy. Okay. So our standard deviation is 10.4. So let's try to do that here. Right. So in Python, you can see all those steps we went through just to calculate our standard deviation. But here, just one step. I'll just have let me have std. Let me call it like this. So this is my variable. So np.std. This is the function standard deviation. So I'll just pass the array here. So let me just pass standard deviation to my stuff here. The standard deviation is, you can call it std def. Oh, std def. So if I run this again, now standard deviation is 10.41, so the same thing here. So we have 10.4, right? We'll just approximate it here. So Python is giving us 10.416 43 is 3333 times 27 and 99983, right? So it's the correct. So you can see how it works, right? You can see how it works. So now we can still do for variance. So variance is the average of the square differences from the mean, right? Variance is the average of the square differences from the mean. So all I just need to do, let me just put variance here. So it's just np dot the val. You can see the function here. You can see the function here. So I passed it. So remember, variance is the average of the square differences from the mean, right? So there are other statistical analysis, right? But these are the key ones we're looking at here in this course. So you can see how easy it is using Numpy. Like I said before, Numpy is very, very good for matrix calculation, right? It's for linear algebra. So it's very, very good in linear algebra. The tool is very good for matrix calculation, right? So and other mathematical calculation. But this is not analysis class. That's why I just use the descriptive analysis to demonstrate this. Okay, there's other things I want to show you guys here. The first we haven't actually do the first quarter, second quarter, and third quarter. Okay, now how is the, I think we have done with the standard deviation. So let's look at how to calculate the first quarter and the second quarter and the third quarter, right? I think. Okay. So now steps to calculate the quarter or percentile. Now to sort the data, the first thing we need to do is to sort the data, to sort the ages. So we now have 23, 34, 45, and 50. So the second step is to calculate the position of each percentile. Now to find the percentile value, use the formula for the percentile position, right? Which is the position equal to the percentile we're trying to do. If it's 25%, right? So if it's 70, if it's then 50%, right? Or 75%. So or 7. So we have the percentile divided by the 100, right? Times n plus 1, right? Where n is the number of observations. So we should see that here, right? So let's say we want to calculate for 25 percentile, right? So the first quarter, which position for Q1 is equal to the 25 divided by 100 times the 4 is the total number of what we have here in the array, which is we have 4 elements. We have total number of 4 ages here, right? 1, 2, 3, 4. So that's what we have. So the calculation is the 25 divided by 100 times 4 plus 1, which will give us, if we divide this, we give you 0.25. If we add this, we give you 5. Which 0.25 times 5 will give us 1.25. Now it doesn't end there, right? So since we've gotten 1.25, so you can see here, we've written here that the position 1.25 indicates that Q1 is between the first and the second values in the solid list. So if you look at the solid list here, we have 1.25, so Q1 falls in between the first and the second list, which we have 23 and 34, right? Which is 23 and 34. Right, so we'll perform the interpolation here, where we now have, using now the Q1 will now be equal to the 23, which is the first element, right? 23 plus. Now, if you check here, remember that the 1.25 indicates Q1 is between the first and second quarter, right? So let's assume the 1, we are taking it out, so the remainder is 0.25, so that's what we had here, right? The 1, we already detected using the 1 to detect the first and the second, right? The first and the second element, right? So the remainder here is 0.25, which now the 23 plus 0.25 times the second age, which is 34, minus the first age, right? So this calculation using the tabulation pattern, so equals to the 23 plus 0.25, right? Times 11. The 11 is 34 minus 23 will give us 11. So will give us this will give us 23, right? Plus 2.75. So that will give us our answer, right? So the same thing applies to the 50% quartile, which is a median, right? So the same way, the same pattern, which is 50 divided by 100 times the total number of elements we have in the array plus 1, which should give us 0.50. If you divide this times 5, will give us 2.5. Now this falls in between the 2 and 3 because the 2.5, right? So that's why we'll collect the position 2 and 3 here, which is 34 and 45 in our sorted array list. So the remainder here is 0.5, right? So that's why in the interpolation, so we median will now be the 34, right? Which is the second one, plus the 0.5 times 45, which is the third, minus 34. It's the same pattern with a 25% quarter, right? The same pattern. So we now have 34 plus 5.5 will give us our answer. So the same thing applies to the 70% quarter, right? Same thing applies to the 70% quarter, where we have 70 divided by 100 times 4 plus 1, which is the third quarter, which is 0.70 times 5, 3.5. So this one, the 70% quarter falls in between the 3 and 4, the index 3 and 4, right? Index 3 and 4, you can call it position 3 and 4, right? Let's say it falls in between the position 3 and position 4, not index. So position 3 and position 4, not index. So now you can see we collect the position 3, which is 45, and position 4, which is 50. So the remainder here is 0.5. So you perform the same calculation and we end up at 47. Now using the Numpy, right? So all this calculation, we can do that here in Numpy, right? We can perform all this in Numpy because we already have a function called we have a function called the center a Numpy. So all I just need to do is this. So for me to get my 25, my first quarter, let me call it 25 quarter. Sorry, let me just let me use okay, let me put percentile. Okay, let me put percentile 1. Percentile pound, which is np dot percentile. You can see the function here. So I'll pass my array here. Then I'll pass in my 25%. So I will do for the second quarter, which is 50%, is percentile 2. Then I'll do for the third quarter, which is 70%, which is percentile 3. Okay, so if I pass these here, first quarter, first quarter is percentile 1, second quarter, percentile 2, and the third quarter, percentile 3. Okay, so if I run this pi, no, pi, So you can see what happens here. So you can see just one line of code, right? Just one line of code, but it's necessary that anything you're learning is good to understand the mathematical concept and the theoretical concept of that particular function to enable you to modify and to manipulate it and to like integrate it with other functions, right? To get you started. Now you can see that we explain how the quarter is being calculated, that the standard deviation is being calculated, the mass, mean, median, mode. We didn't actually do mode here, right? So don't worry, we'll do it using pandas just because of time. So now the descriptive analysis of the age in our data set are the mean, right? We've gotten this. You can see the third quarter is 45.5, and I think we got that here. Although we have 47 in the third quarter, right? So we don't know, but here, what we have here is the third quarter is 45, if I'm correct, 45.5. Right. So just follow the same principles and you get it done. So I hope you understand this video. The next video we're going to look at pandas definition, manipulation, and then we're going to get started, really good started with the data science class. So thank you and God bless you.